After watching this video lecture, students are going to be able to manipulate the density equation and solve for any of the variables therein. And students are also going to be able to convert between Celsius and Kelvin temperature scales. So the density equation, D equals M divided by V. The D stands for density, the M stands for mass, and the V stands for volume. And each of these variables obviously are able to be isolated through manipulation. You can subsequently solve for whichever one that you desire. So if we just look at that really quickly, if we cross multiply, okay, we're going to get dV equals M, so density times volume equals mass. That's a really quick relationship there. If we want to isolate the volume, we would divide out the density. Okay, so we would end up with volume being equal to mass over density. Okay, so honestly, the interchangeability of the various units just requires a little bit of mathematical manipulation, and we can subsequently get what we need. Now, anytime we have an established equation and we're needing to plug in variables, we need to make sure that we manipulate the equation like we're seeing here, and being sure to isolate all of the variables before we plug any numbers in. So in my class, you need to manipulate the equation, solve for the variable, and then plug your numbers into the equation. So we have a problem here, this density problem. They have told us that we have an object with a volume of 825 centimeters cubed, okay, and a density of 13.6 grams per centimeters cubed, okay, and they want us to find its mass, okay. Well, we know that the density equation looks like this, but they don't want us to solve for density. They want us to solve for mass, okay. So we're going to cross multiply. Remember, dV equals M, okay, and then now that we have our manipulated equation, we are going to subsequently plug in our variables, okay. So if we look at this, we have density, which is 13.6 grams per centimeter cubed, times volume, which is 825 centimeters cubed, and that is going to be equal to our mass. Now we're going to go ahead and we're going to multiply our 13.6 by our 825, and that's going to give us the following answer. And then we are going to check our significant figures. We're multiplying here, so 13.6 has 3 sig figs and 825 has 3, so we need to have 3 sig figs. So this is going to be our final numerical value. And then we do a unit evaluation. Centimeters cubed canceled. We end up with grams on the bottom. So this is going to be the mass associated with this particular object. If we go ahead and do another practice problem here, we've been given the mass of our object, we've been given our density of our object, and they're wanting us to give them our volume in milliliters. Okay, so if I have my density equals mass over volume equation, and I want to get a volume by itself, I'm going to cross multiply and end up with the following. Okay, I isolate the volume by dividing through by my density, and so my volume is going to be equal to mass divided by density. Okay, and then now that I have my manipulated equation, this is what I'm going to be looking for. I then need you guys to plug in your values. So we have 225 grams divided by 444.1 grams per centimeter cubed. Okay, we go ahead and we plug that into our calculator. That's going to give us 0.50664. As our volume. Okay, if we go ahead, we consider sig figs, 3 sig figs versus 4. Our answer should have 3 sig figs, so that's going to be 0.507. Okay, and then when we look at our units here, okay, we have grams divided by centimeters cubed. Okay, dividing by a number or its units is the same as multiplying by its reciprocal. So that will actually be grams times centimeters cubed over grams. Grams and grams cancel. I end up with centimeters cubed. Okay, now centimeters cubed is what we have here. Okay, but what we need to know, guys, is the cool thing about the metric system is that 1 centimeter cubed is the equivalent of 1 milliliter. So when you see centimeter cubed, you should automatically think milliliters. Okay, so our final answer here is going to be 0.507 milliliters of the liquid. So now that we have density down pat, let's go ahead and look at temperature conversions. Today we're going to be focusing on Celsius and Kelvin interconversions. A couple of things. First of all, I want you to notice that there is no degree symbol. See this degree symbol you see right here? Okay, there is no degree symbol for Kelvin. So we just say 10 Kelvin. We don't say 10 degrees Kelvin. So please make sure that you're not including a degree symbol next to the Kelvin. I will mark you off for that. Okay. Additionally, Fahrenheit, obviously that's what we use in the United States to indicate temperature. But most other places use the metric system and focus on these two temperatures. So I'm not going to make you do any conversions with Fahrenheit, but we're going to focus instead on Celsius and Kelvin. So Kelvin is related to Celsius by this value here. So degree C plus 273.15 is going to give you your temperature Kelvin. So if I have a Celsius temperature, I add 273.15 to it, and I'm subsequently going to get Kelvin. Same thing, if I have a Kelvin temperature and I want to get into Celsius, I'm going to subtract 273.15 from that Kelvin value. Okay, so if we look at a quick practice problem, we've been given 22.2 degrees C and we're converting to Kelvin. So remember, Kelvin is degrees C plus 273.15. Okay, we're going to plug in our Celsius, so 22.2 degrees Celsius plus 273.15. It's going to be our new temperature in Kelvin. We add that together, and that's going to give us 295.35. Okay, now we're going to look at our measured value, and because it's addition, there's one place to the right of the decimal, so our answer is going to have one place to the right of the decimal. So our final answer is going to be 295.4 Kelvin. So simple conversions. Make sure that you can do each of them, and you should be good.